Picture this for a second. It's April 2026. A luxury cruise ship set sail from Ushuaia, Argentina. You've got 150 passengers from 23 different countries, all heading toward the incredibly remote islands of the South Atlantic. For the first few days, it's an absolute dream vacation. But beneath the surface, a microscopic threat has already boarded the ship. What starts out as just a mild fever in one single passenger rapidly spirals into this mysterious, fatal outbreak. It literally turns the vessel into a floating crisis, getting rejected by international ports. Today, in this explainer, we're unpacking the reality of the Hantavirus. We're going to break down its epidemiology, its evolutionary links to climate change, and exactly what it means for both global and localized public health.
Okay, let's dive right into this. Here's our structured syllabus for today. We'll cover the clinical threat, the disease syndromes, chronology and ecology, the Indian context, pandemic potential, and finally mitigation strategies. Starting with Section 1, the threat, a clinical emergency at sea. 50%. I want you to just let that sink in for a moment. Up to 50%. That is the mortality rate for certain severe strains of hantavirus. To put that into perspective, this virus can kill half of the humans it infects. And here is a really critical policy gap you should note. Despite scientists knowing about this virus family for over 70 years, there is no cure. There's no FDA or WHO approved vaccine and absolutely no proven antiviral treatment. If you catch it, survival depends almost entirely on supportive care and your own immune system.
So, how did this specific ghost ship scenario actually unfold? Well, the exposure happened in March, right before departure. A Dutch couple visited a rat-infested landfill during a bird-watching tour in Argentina. They boarded the ship on April 1st. By April 11th, the 70-year-old Dutchman, who initially just had a mild fever and some diarrhea, suddenly suffered severe respiratory distress and passed away right there on board. His wife then disembarked in Africa, flew all the way to Amsterdam, collapsed at the airport, and unfortunately died on April 26th. By early May, a German passenger also died, and that's when the official notification went out to the World Health Organization. It was this rapid, devastating chain reaction triggered by just one single environmental exposure.
Moving on to Section 2, Scientific Specifications and Disease Syndromes.
Now, what's really fascinating here is the stark regional contrast in how this virus actually attacks the human body. Hantavirus isn't just one single pathogen, it's a family of viruses. And depending on the strain, it causes one of two primary syndromes. Over in Asia and Europe, we see HFRS. This one goes straight for the kidneys, causing internal bleeding and renal failure. But over in the Americas, the strains cause HPS, and that's the syndrome that hit our cruise passengers. HPS targets the lungs, causing them to rapidly fill up with fluid, which leads to suffocation. Understanding this geographical and pathological split is an absolutely vital specification for any public health assessment you might do.
Which brings us to Section 3, Chronological, Evolution, and Ecological Links. To really understand how we got here, we have to recognize that this is definitely not a new threat. We need to look back over 70 years of virology. The virus first grabbed modern medical attention during the Korean War back in the 1950s. Over 3,000 American soldiers fell gravely ill with fever and kidney failure, seeing a 15% mortality rate. It actually took nearly 30 years to solve that mystery. It wasn't until the 1980s that South Korean virologist Dr. Ho Wong Lee finally identified the pathogen, naming it after the Hantan River. Fast forward to 1993, a sudden, deadly respiratory outbreak struck the Navajo community in the American Southwest. And then, in 1996, we saw a major evolutionary twist in Argentina with the discovery of the highly aggressive Andes strain.
Now, this part is incredibly important, especially when we talk about the climate health nexus. During that 1993 Navajo outbreak, there was an extreme climate event, a massive El Niño. This brought unusually heavy rains, which led to a bumper crop of pine nuts. And what do pine nuts bring? An absolute explosion in the local rodent population. That population boom triggered a severe zoonotic spillover directly into the human population. So as you can see, extreme weather acts as a direct, powerful driver of viral transmission. It's like a giant, deadly domino effect.
All right, Section 4, the Indian context, localized risk assessment. For a very long time, people assumed that hantavirus was strictly an Americas or East Asia problem. Well, let's dismantle that assumption right now by looking at the localized risk right here in India.
Between 2005 and 2008, there was a landmark study done in Tamil Nadu's Vellore district. They confirmed 28 cases of hantavirus and revealed some very clear occupational hazards. The virus heavily targeted 3 vulnerable demographics. First, patients already dealing with chronic kidney disease. Second, informal warehouse and godown workers. And third, members of the Irula tribe, whose traditional occupation actually involves catching rats. This study definitively proved that occupational and socioeconomic vulnerability are massive risk factors here.
And here is the most striking data point from that whole study: 4%. When researchers tested over 600 individuals across various risk groups, they found a 4% seroprevalence. What does that mean? It means hantavirus-specific antibodies were present in roughly 4% of the general population they looked at. This is a profound epidemiological revelation. It tells us that this silent threat has been circulating completely undetected in India for decades, mostly concentrated around populations living or working in close proximity to rodents.
Let's move on to Section 5, Pandemic Potential and Transmission Mechanisms. Given that scary 50% mortality rate and its global presence, the immediate question on everyone's mind is naturally, is this the next global lockdown? Well, let's look at the actual scientific data. First, we need to talk about the Andes virus strain. Discovered back during that 1996 outbreak in Argentina, the Andes strain is the exact same variant responsible for the 2026 cruise ship crisis. Why is it so special? Because out of the entire hantavirus family, the Andes strain is literally the only one historically documented that is capable of human-to-human transmission. Plus, scientists have documented that certain individuals infected with this specific strain act as superspreaders, infecting an unusually high number of their close contacts.
But hold on, before we start panicking, let's establish some conceptual clarity. We have to contrast this with what we know. Unlike COVID-19 or the flu, which we all know are highly infectious, spread through the air, and require strict 14-day quarantines, hantavirus is not airborne. For the Andes strain to actually jump from one human to another, it requires very close, prolonged physical contact or direct exposure to bodily fluids.
Let's systematically break down why a global pandemic is actually highly unlikely with these 3 distinct biological facts. First off, it has a remarkably brief transmission window. An infected person is typically contagious to others for only about a single day early on in their illness. Second, as we just established, it doesn't spread through the air. And third, it requires incredibly intimate contact. We're talking about things like sharing a bed with someone who is infected, or providing extremely close medical care without proper protection. Because of those factors, widespread community transmission is incredibly difficult. And this is exactly why the World Health Organization has definitively stated, quote, "The overall risk to the global population is low." As a focus learner, especially if you're analyzing public health policies, it is absolutely vital to separate the dramatic 50% mortality rate of a single individual infection from the broader epidemiological transmission rate. Yes, the disease is devastating if you catch it, but the biological barriers to it spreading across the entire globe are thankfully very high right now. Finally, Section 6, The Way Forward, Prevention and Mitigation Strategies. A low pandemic risk certainly doesn't mean zero risk, right? Especially not for our most vulnerable communities. Since we don't have a cure or a vaccine, awareness and solid public infrastructure are quite literally our only lines of defense. Here are the actionable, syllabus-ready mitigation steps required. Step 1. Structural mitigation. Building codes must ensure that homes and storage facilities are completely sealed against rodents. Step 2. Occupational safety. We need to mandate PPE, like N95 masks and gloves, for informal and warehouse workers who are going into high-risk unventilated zones. And Step 3. Civic hygiene and strict municipal waste management. If you remove the food attractants through proper cleanliness, you break the chain of transmission before it ever even reaches a human being. We've seen how something as simple as heavy rainfall driven by El Niño can trigger an ecological cascade that ends in real human tragedy. So, the question I want to leave you with today is this. As climate events continue to alter wildlife populations, are we actually ready to adopt a One Health approach? Is our public health infrastructure truly prepared for the hidden zoonotic threats just waiting out there in our ecosystems? Chew on that as you review these concepts. Thank you so much for joining me on this explainer. Keep learning and stay curious.